Good day, everybody. My name is Azrael Rex B, and once again, I'm back for another output explanation video. So this one is going to be for task 2, the prediction using unsupervised machine learning. So we have back-to-back machine learning tasks, task 1, task 2. This is the task 2 of the, once again, Sparks Foundation, also known as GRIP, Data Science and Business Analytics Internship. So without further ado, let's get on to it. Additionally, this is going to be the post that I'll be posting later on this dataset. This is the GitHub. It's right here. If you guys want to like follow along, you just open this link right here. And then this is going to be the link if you guys want to sign up. This is actually a pretty good internship. Yeah. Uh, Granted, you need to be someone that is very like strong emotionally and have life perseverance because it's entirely self-learning. No one's gonna be teaching you. Just gonna giving you tasks, and it's up to you to find ways to solve them. And in a way, that's how data science and that's how programming, being a developer works. So it's actually in your paper. So this is the bullet point. So we use like supposed to be array. Sorry about that one. So we use popular libraries such as, numpy, pandas, matplotlib. This like the previous task, but this time we've been using seaborn and inline. And once again, we're going to be using scikit-learn, this time with clustering, and there's actually going to be much more since I figured out that clustering alone is not gonna cut it. So without further ado, let's get started. So like always, we have the name, start of the video. It's also at the end of the video, because just to be sure. Okay, so let's get started. Okay, so the objective is to utilize unsupervised learning, specifically DK, which stands for the clustering algorithm, on the iris dataset which was given to us by the Sparks Foundation. Identify what is the most suitable number of clusters within the dataset, furthermore visually present these clusters. So dataset is actually here. So I'm just gonna open it, but I downloaded the dataset. The dataset is actually over here. It's really the same. Anyway, this is it in spreadsheet or Google Sheets form. So as you can see, we have Irish version color, and then we also have Iris Setosa, which I will be tackling later on. So let's get back to it. Okay, so again, this is literally not anything. This is just when you press Shift Enter, it appears. Okay, so first we'll start off with importing the necessary libraries for this task. So I started off with numpy, matplotlib, pandas, seaborn, inline, but then I realized, hey, we actually need to input more. So over here. Okay, so just insert data using different method this time. So I tried to do this Irish method. I don't, it didn't work. And I tried to AI it and it also didn't work. So I was just like, hey, there's a learning process, let's try something else. Developing is about failing. Same thing with data science, because this is actually straight up coding. I mean, Python makes it a lot easier to code less than other languages, but still. Now it's time for us to be able to display the initial rows of the dataset as the iris command above does not work, but that is okay as this is learning process. Okay, so let's use this iris that underscore data that head command, and we see the initial ports. Now the entire dataset is actually over here. So this is just that I'm just like trying to figure out what is happening here. So I think this means this is like the degrees of freedom, from what I remember from my statistics. I imported dataset and I displayed the initial rows. I checked permission values. Actually, did not do that. So let's remove that. I was gonna do that, but then I realized that wasn't necessary. I showed the entire dataset. I imported the data and set it up in a hierarchy format. I executed data pre-processing, which is my first time and actually worked. I had some help with Google and AI Poe. Train the model, visualize the model cluster, show the before and after classification. You will see later on that's there down below. Provided a strong conclusion with the task and I successfully finish it as well. Okay. If it doesn't work for some reason, I will now move on towards the data exploration stage. Doesn't work because I did it incorrectly. Okay. So we imported more. So some scikit-learn, DSBS scans, linkage, yeah, decomposition. Here you go, cluster. Actually, just clustering. It's just abbreviated cluster. We have metrics too. I think I'm addicted to pressing shift enter. Okay, so now I figured out I need to import more libraries such as numpy array and utilize a different command to be able to show my entire dataset here in Jupyter Notebooks from scikit-learn import datasets. Okay, so here's the actual data. This is literally just the CSV file. I just imported it here. That way I could see it better. Okay, so target name. So we have Setosa, Verticolor, and Virginica. So these are like when I showed you the dataset earlier, you see like on the section to the side there was like names. So that that is what this is. This is the one that's the most notable to me because it appears later on in my conclusion. Now it's time for me to input dataset and insert it up in a hierarchy. Okay, so we're gonna be plotting it. Okay, so just look at this code, analyze it for yourself. Okay, so we have some visualization here. So this is the iris hierarchical clustering dendrogram. So this is actually my first time using a dendrogram. Seeing as the plotting went well, it's now time for data pre-processing. Let's put period down. Okay, that's over. It's time for model training. Okay, this was actually supposed to appear earlier, but it appeared here. So let's just roll with it. Okay, that doesn't matter. That doesn't matter. I'll now show you what the cluster looks like. This is the model. This is actually what you need to see. If any non-data people are watching, you probably don't understand anything at all, but all you need to see are the graphs and just listen to the explanation then. So this is before the classification, this after. As you can see, the green lines are scattered towards like the opposite side. So they're over here now as opposed to like over down here. The red lines are the same. So what does that mean? That means, it transitioned to over here. So confusion matrix calling names along the top represent the predicted class labels. So the labels, those are like the green ones, right? While the row names along the right side predicted class labels 0, 1, and 2. So 0, 1, and 2, right? Yeah, 0, 1, and 2. So 0, 1, 0, 1, and 2. Right side represent the class name, which is Irish, Sesosa, what I was saying earlier. Where's that? Hang on, I can't seem to find. No, no, no. It's down here. It's down here. Wait, where is it at? Oh, it's right here. Yeah, there you go. Okay. Each cell within the matrix represents the count of instances where a true class label was classified as one of the predicted class labels. So essentially, we successfully produced a data visualization that showed us the three class labels, and then we are now able to see what is the difference between all of them. Yeah. So these are not concrete. These are just predicted. But then again, that's the beauty about machine learning. There's a lot of theory crafting. Anyway, we're done with task 2 now. So I don't know if I explained that as well as I thought I did in my head, but I'm always open to my suggestions. This is the second time that I'm doing this, so feedback is always greatly appreciated. So follow along with the source code. Let me know what I did wrong. Let me know what I did great. Give me some feedback. Give me some peer evaluation, and yeah, all that good stuff. So thank you for watching, everybody. Bye bye.